Okay, so finally we're going to implement our tokenization algorithm, a very simple one that with the things that we've learned in so far. So before that, I just wanted to show you that there are two websites that they explain how regular expressions work, and I think you are gonna benefit from taking a look at them. So one of them is called regex101.com, and the other is regexr.com. They both do the same thing, so I'm gonna show you what the 101 does. So if you search, let's say that I have a string, let's say that I had any of those strings that I had used in the previous videos. So let's say this one here, and I put it here, and then if I just say ABC, then it shows it's processing. So it shows all the places where it matches ABC, and then I can click somewhere to replace. How do I do that? Substitution here. So it's exactly the same idea as Python. So let's say that I want to substitute, to replace all the ABCs by DEF. Then it takes the input string here, shows all the cases when ABC matches this thing here, and then it shows the output here. It replaces all the ABCs with DEF. So I think that, and then you can, for example, have groupings, right? As let's say that I want to find either ABC or 1, 2, 3, and then I want to replace each ABC with, so since I have only one grouping here, so there is only one thing that I can refer to, but like the idea is, let's say that I want to put spaces around, then I can use the groupings here, and it colors the things in the same way. So if you see here, these are green, so it makes all them all green here because they match this grouping here. So if I had another grouping, so let's say that I had ABC and I had like another ABC, let's say. So then it colors these as a second group, and then if I put /2, then you can know that this is the grouping. You see that it's written there, group 2. So this is just a website that is probably useful for you. And also, since the syntax of regular expressions is so horrible, there is this explanation of what it is doing that could probably help you in understanding what's going on. So hopefully this is useful for you to play around with regular expressions. The other side does exactly the same, only the interface is a little different, but it does exactly the same thing. So I will leave this, and I'll go back to our explanation, to our implementation of tokenization. So, okay, so how are we going to tokenize? I created a line here that I want to tokenize, and I am going to copy here. So it has all sorts of horrible punctuation and stuff that we probably don't want, like this and this and this and this. It even has this thing here. So the first thing that we want to do is, if you remember, we had a list of special characters that we want to find and put spaces around them. So I actually have a line here that shows all of them. So the idea is I want to create a grouping here where, in the same way as we did in the previous video, where we want to find any of these characters here. So it has to be either single quote, or a dot, or a comma, or any of these things. And whenever we find one, we want to put spaces around them. So when I run this, I first have to run the line. And then when I run this, then let me just show you the line. Then it puts spaces around all of these, as you can see. now the next thing is, okay, so now we have too many spaces, right? If I call line.strip split, and I give a space here, then it creates these things, that these like strings that are empty, so strings that don't have anything. So I don't like this. So what we want to do is to remove the spaces. So the way to do this, we already learned in the previous video, was to do this, to use to search for any number of one or more spaces, so at least one space, and replace by only one space. And then when I give line here as the input to this function, and I output to line itself the result. So this would, like, this way I get the output here, but I want to assign it, to store it in a variable, and by chance I'm giving the same variable here as was the input here. So I'm overriding the value that was inside this variable. So when I do this, then now line has this output, and you see the spaces, the multiple spaces are gone. Now the problem is we have a trailing space here. So as we already learned, we want to line strip, and I'm gonna just print the line, show the line for you, and then the line disappeared, this trailing space disappeared here. And then finally we can just do line.split. And so another thing that split does is, so if I don't pass any parameter to it, then it doesn't only look for the space character, this character here, it looks for any space character. So it includes tab characters and enters. So I'm just not going to pass anything to the split function here. So as I do this, then we have a simple tokenization. So things that are important to pay attention in this tokenization. One of them is, you see the apostrophe S here is separated, right? So we probably would want to do something with our data here to fix the apostrophe S here, if you wanted to keep this as only one word. Another option would be, we just don't include this thing here, this thing in the apostrophe in our list of characters, and then Bob's here would be together, like would remain together. Another thing is, if we had something like m.sc dot, then this would be split as 4 tokens. So maybe we have maybe this would require some more thinking. But my point here is just to show that a very simple knowledge about how regular expressions work is sufficient to generate tokenization, your own tokenization algorithm that is, and then you can implement whatever choices you want to make instead of those that the NLTK uses. Just to remember how the NLTK did this, I actually have copied some lines here, have gotten some lines here just to remind you. So what we would do would be to take this string here. So let me take line here, and we had to import NLTK and then import the word tokenize from the NLTK, and then say NLTK.word tokenize, and pass line, and then it would tokenize for us. And here you can see that it kept the apostrophe S together here. So that's it. So in the next video, we are gonna just have some concluding remarks on tokenization, and this is going to be it for this week.